So this is part B of exercise 5, or no, see, I keep saying exercise 5. Exercise 6 from week 7. It's 6.2.17 in the study plan. So it's another problem to find the probability that an observation falls in the shaded region. And so remember, when we say probability that an observation falls, we're just talking about areas under the curve in this case. So we want to know how much of our observations fall within 1 and 51/100th standard deviations of the mean. That's what this means here. So we're going to have to use a couple pieces of information. From that, we know that the z-score that we are interested in here and that we're going to be using is 1 and 51/100ths, and that's just because that's how many standard deviations we are away from the mean. That's how we know what the z-score is. And so what we want to do, I'm just going to write this in another way, we want to find the probability that we have this z-score between negative 1 and 51/100ths and positive 1 and 51/100ths. And so in this problem, I'm going to use the z-tables, and the only thing that we can do as far as finding things out from the z-table is finding area to the left of a particular z-score. So in order to find area between, we're going to have to look up two z-scores and take the bigger area, subtract it from the smaller area to get your area between. So first thing that you're going to do is look up 1 and 51/100ths on your z-table. So the way you're going to do that is go to 1.5 and then go over to 0.01 to get the 100th part, okay, or yeah, 100th part. And from the table, hopefully you can check with me here and make sure that you see where I get 0.9345 for that area. And that's making sense as far as like, does that area seem reasonable? If we got something like 0.002 here, that wouldn't really make sense because this area under the total curve is always going to be 1. And so it wouldn't make sense that we would have something smaller than 1. Something far away from 1, because this is a large portion of the curve that we're looking at here. So that's our green portion, and now we're going to subtract this red portion here, where we have the mean minus 1.51 times the standard deviation. So this is negative 1 and 51/100ths away from the mean, or another way of saying that is just that our z-score is negative 1.51. So hopefully, just like you did for the green, you can go into your z-table and see that if you go to negative, your negatives are really important here. It's going to change that answer pretty drastically. So make sure you're paying attention that you have a negative z-score. You're going to have negative 1.5, and then you're going to go down to a negative 1.5, and then go over to 0.01 to get the negative 1.51. And then hopefully on your own z-table you can see where I'm getting this 0.0655. Okay, so now we have the green area and we have the red area. What we want is this blue area between these. So can you see, if I take this green area and I erase the red, that I'm going to be left with the blue. Okay, hopefully you can see that. So let's do that math. So we're going to take our green, the 0.9345, and we're going to subtract our red, 0.0655, and we're going to end up with 0.869. And that makes sense thinking of the empirical rule, right? Because within 1 standard deviation, we have 68% probability that we're within 1 standard deviation of the mean, and 0.95 probability that we're within 2 standard deviations within the mean. So we would expect this to be less than 0.95 because we're still within those 2 standard deviations. So hopefully that makes sense. And if you have questions, just let me know. I have a different camera now, so I'm kind of like looking in weird spots, but hopefully you're able to pay attention and do okay. All right, bye-bye.